Morning, everyone. Dr. Bond. I'm going to make a quick video for Chapter 6.1 homework. We're going to see how many of these we can get through in a very short period of time. I have number 15 pulled up here. This is about tiling the floor of a museum. It's 65 feet by 85 feet. So we want to do the factorization of these dimensions to see what kind of tiles can fit in there. So 65 is 5 times 13, and 85 is 5 times 17. So the other thing I'm going to point out is that this is the largest size square tile. So we couldn't do something like a 13 by 17 tile. That would work for tiling this entire floor, but it wouldn't be a square tile. So the greatest common divisor between those two numbers, 65 and 85, is actually just 5. So I think the answer here is we have to do a 5 feet by 5 feet tile. All right, now we're going to go all the way back to question 1 and just see how far we can get through starting at the beginning. All right, 27 is a multiple of 9. That's a true statement. Okay, now we're doing a test for divisibility. The test for divisibility by 2, of course, is that it's even. The sum of the digits is the test is divisible by 3 when the number is divisible by 3. The last 2 digits are divisible by 4. When it's divisible by 4, it ends in a 5 or a 0 when it's divisible by 5. Both the tests for 2 and 3 work when it's divisible by 6. The last 3 digits are divisible by 8 is the test for 8. The sum of the digits is divisible by 9 is the test for 9. And of course, divisible by 10 is when it ends in a 0. So this one's even. It is divisible by 2. We'll take the sum of the digits. 7 plus 2 is 9. 2 and 10 makes 10, so that's 19. Plus 6 is 25. 25 is not divisible by 3. Is it divisible by 4? We're looking at these last 2 digits. 80. 80 is divisible by 4, so therefore the whole number is divisible by 4. Divisible by 5 because it ends in a 5 or a 0. Divisible by 6, it would have to be both 2 and 3. It was not divisible by 3, so therefore it cannot be divisible by 6. And divisible by 8, we're looking at the last 3 digits, 280. So trying to divide 8 into 280 into 280. You have 8 goes into 24 3 times. That's 4 left over. 40 is 5. So it is divisible by 8. And finally, divisible by 9 is when the sum of the digits is divisible by 9. But we already did the sum of the digits, and it's not divisible by 3. So therefore, it can't be divisible by 9. And it ends in a 0, so it is divisible by 10. All right, so the numbers from this list that divide 726 is just summarizing what we did before. 2, yes. 3, no. 4, yes. 5, and then 8 and 10. Okay, determine all values of D that make this statement true. So you have 8, 7, 3, 3, 5, which is not divisible by 2. And so we need D to be some kind of a multiplier of 87,335, which is going to make this divisible by 4. And so any multiple of 4 is going to be a proper response here. So it looks to me like we can put, and I think they're only talking about single digits, so I think 4 and 8 are the two values that will work here. Oh, I'm sorry, I misunderstand. So they actually want D to be the last digit. So we need 5 blank to be divisible by 4. So okay, I just misunderstood what the statement was. So let's see, 50 is not divisible by 4. So 52 would be divisible by 4. 54 is not divisible by 4, but 56 is divisible by 4. And then 58 is not divisible by 4, and then we're all the way back to 0. So I think the only digits here are 2 and 6. Okay, use a calculator to determine if the first number divides the second. Let's see, I'll get my calculator here. So we'll take 37,949 divided by 649 and get 58.47, so no, it's not a divisor. Provide a counterexample to show that the following statement is false. If 39 and 9 both divide A, then 351 divides A. So let's see, we need to find something that 351, I suppose, is 39 times 9. Okay, so first they ask us about the problem-solving method that should be used. This is the counterexample principle. And then we have 39 and 9 divide A, then 351 divides A. So what we're going to do is take 39, which has 3 times 13, and multiply an extra 3. So 39 times so that would be 3 squared times 13. So that gives us 117. And 117 is divisible by 9 because it has 2 3's in it. And 117 is divisible by 39 times 3. 13 times 3 is 39. But of course, it can't be divisible by 351 because it's smaller than 351. All right, number 6, use the sieve of Eratosthenes to find all prime numbers between 51 and 100 inclusively. I'm going to skip this problem only because it's kind of paper intensive. So you have to take all the numbers between 1 and 100, or between, start with 1 and 100, and you cross off like 1, and then you circle 2, and you cross off all the even multiples of 2, and then you circle 3, which is the next prime number, and you cross off all multiples of 3, and then you circle the next unmarked number, which would be 5, and then you cross out all the multiples of 5, and then you circle the next uncrossed number, which is 7, and then you cross out all the multiples of 7. You only need to do this up through 10, so actually after you've done 7, you're finished, because everything will have been marked between 1 and 100, and then any number that's not marked after you've done all the multiples of 7, those are going to be the prime numbers between 51 and 100. And then you just list them here as you go across. All right, so we're going to factor 79. So let's see, we can use the kind of prime, the test for divisibility. It's not divisible by 1, 2, well, it is divisible by 1. It's not divisible by 2, not divisible by 3, 4, 5, no. So the only thing that it could potentially be divisible by is 7, but it's not divisible by 7, so this number has to be prime. All right, so 2205 is certainly divisible by 5. So it's not divisible by 2. Let's see, 5 plus 4 is 9, so it is divisible by 3. So let's start with the 3. And let's see, we'll do times. I wonder if we have a times operation. 3 times, okay. Now we'll pull out the 5. So if I divide by 3, I get 7 and 3, 735. So 735 now divided by 5 is 1 and 4, 7, 147. 3 times 5 times 147. 147 is 7, and 4 is 11, plus 1 is 12. So actually it is divisible by 3 again. Let's go back this and actually factor out another 3. So that gets us down to 4 and 9, 49, which is 7 times 7. So I have 3 squared times 5, and then times 7 squared. Uh, 351. So again, we'll do the, it's odd, so it's not divisible by 2, 4, 6, 8, or any of that. We'll do the sum of the digits. 3 plus 5 is 8, plus 1 is 9. 9 is divisible by 9, and so we're going to factor out 2 factors of 3. So when I divide by 3, I get 1 and 1 and 7, 117. So that's 3 times 117. 117 is also divisible by 3. So we're going to get 2 factors of 3. This is actually the same number we had just a few minutes ago on that other problem. But once I pull out that second factor of 3, that 117, so that gives me 3 and 27 is 39. So 3 squared times 39. I'm sorry, 3 squared times 13. No, I think I was right the first time. 3 squared times 39, which is 3 cubed. 3 threes times 13. Find the greatest common divisor and least common multiple of the following pairs of numbers. There's actually, if you have a TI-8384 calculator, there's a GCD and LCM button that's kind of built into that, and you can learn how to use that. But in general, I like to use the factorization method. All right, so 459 is 3 cubed times 17, 27 times 17, 3 cubed times 17. 561 is 3 times 11 times 17. So the common factors here are one common factor of 3 and a common factor of 17. So the greatest common divisor is going to be 51. That's 3 times 17. And the least common multiple is going to be 3 threes, an 11, and a 17. So that's 27 times 11 times 17 is 1683. Looks like I made another mistake. That happens sometimes. So hold on just a second. Yeah, I think I said the right thing, but I multiplied wrong. So 3 cubed 27 times 11 times 17 should be 5,049. All right, I'm going to skip this one because it's pretty much the same as the last problem. And let's see, this video has probably gone on long enough. I have a few problems left for you to try, number 6 and then 11 through 14. But we got through about 2/3 of your homework for today. So hope you have a great day and a good start to your Thanksgiving week. I'll talk to you next time.